Good morning. Assalamualaikum. Good afternoon. Okay, before we start to the new topic, I want you to try this question first. This one is from midterm May 2022. Okay, the question asks you to compute the root and the EA. Compute the root, meaning the XR, and the approximate error, EA, of this function. Okay, this is the given function between x0 and x1.3. So this is your range, xl, xu. Okay, using bisection method and also false position method. Okay, so this question, the stopping criterion is, it asks you to stop calculation at 5th iteration. So you just do until 5th iteration only. The rest, you have class before this. Okay, for number 1 is bisection. Let it be number 1. Bisection. Okay, wait, before that, sorry. We extract out the info first. Okay. Now your equation, this is the main equation that you should use. X power 10 minus 1. Okay, then your XL is 0. XU is 1.3. Stop at 5th iteration. What you need to find? XR and also the EA. Okay, so go for the first method, which is the bisection. Remember the XR to calculate for bisection is using this equation. Okay. Then the second part would be using false position method, which is your XR Okay, so try it. Thank you. I share with you the answer for bisection. XR and the EA. You can check your answer. Then you can proceed with false position. Later share with me your answer. The false position. So Peto, what you get for your XR3 false position? 0.2629, right? Ang Yok Ling, XR4, what you get for false position? 0.338, 81 or 82. Okay, depends to the decimal point that you use. XR5, Anis, belum lagi. Balkis, belum lagi. Rabia, doing. Alif, 0.407. About the EA2 for false position? Sabah, have you done? EA2 for false position. What? 45. On your link, what you get for EA2 false position? 48. 48 or 45? 48. Alif, you get 48. 48.1. Try to calculate back your value. EA3 go peto, what you get? EA3 30.8, correct. EA4 Yuk Ling 22.2. EA5 would be 17.1. Okay. Now, how do you know your answer is correct? You replace back your XR into the main equation. Okay, this one until fifth iteration, right? So you replace this into your main equation. Can you get equals to 0 or not? Because for the root, XR is when Y equals to 0. So try to put it into the main equation. If you can get 0, then your answer is correct. 0 here means if you get 0.000 something, consider 0 as well. Okay. If you get clearly 0.5, that is not considered 0 yet. 0.16 for the XR, fifth XR. How about the FP? Here. Bisection equals to 0.6. 0.116. Okay, close to 0. False position. Minus 0.9. False position. Okay, so it crossed the x-axis already. Right. So Because this one, the question asks you to stop at fifth calculation, fifth iteration. If your value is approaching 0, it should be correct already. Unless it asks you to calculate the stop calculation at ES 0.05. Then your answer might be very close to 0 already. Okay, so it depends to the stopping criterion. As long as it approach 0, your answer should be correct. Okay, so I give 2 more minutes for the rest to finish. Let me know if you cannot get the answer. Maybe you wrongly replace the FXL, FXR, sorry, FXU. Or wrongly replace the XL and XU. The next iteration. Okay, while your friend doing that, I want to survey on the midterm date. I post on the if anyone having sub next week 5, right? Anyone having sub or not? How many subject? One only. Sub will start in week 25th, right? We start on this week, if I'm not mistaken. So since some of your friends having sub, I cannot postpone the midterm to the following week because the following week is already week 5. Sub is on week 4. So I need to drag it to next week. Okay. Can we do it on Friday morning, 11 a.m.? Any clashes? No? Friday, 11 a.m. You have any class at that time? No, huh? Sabah, any class? Rabia? Both of you? No, huh? Okay, so clear. 22nd of September, 11 a.m. I will post the detail in CN, the venue and also the topics covered. So the topics will cover CLO1 and CLO2, which is the linear, non-linear equation, which is this one, and also the linear equation. Linear equation, it involves different type of equation. We share. Okay, it will be designed according to the CLO, which is CLO1 and CLO2 for midterm. CLO1 non-linear, which is the bracket and open method. And then CLO2 is the linear algebraic. Linear algebraic here, I will cover whatever topics that we can finish. Linear algebraic here, it will be the matrix. Gauss and LU is the matrix. This is also the iteration. Okay, I will try to cover the matrix part first in order to assess in the midterm. Okay. Confirm, 22nd on September is our midterm. Morning midterm. Okay, morning midterm. At 4 we still have class, which I will just do exercise on the class at 4. Okay, this midterm will replace our class on 29 of September. So 29 here, no class. Okay, replaced by the midterm on the 22nd. Because this Thursday is public holiday. Okay, so 29 no class. Replace to 22nd for the midterm. Okay. Okay, we are done with bracket method. Any question before I move to the open method? Yeah. Okay, just to conclude for chapter 2A, the bracket method. First, last time we had done on the graphical. Okay, this is the bracket method. Graphical, where we will have the range XL and XU. Okay, and here you will need to plot the graph. Then the bisection and also false position, you will need to use equation. Okay, this equation. All of this method, the aim is to find the XR. XR means when X value when Y equals to 0. Okay. Now that is bracket method. You have lower range, upper range. Now for open method, it is also to find the roots, the XR. Okay, but you are given only 1 point. Okay, for open method, we have fixed iteration, Newton-Raphson, and also secant method. Okay, so these are the open method. For open method, you will be given 1 starting point. Whereby the bracket method last time, you have XL, XU. This one only 1 starting point. Okay, so we go one by one. I'll start with fixed point iteration. Where fixed point iteration, okay, this one just to compare between the open method and bracket method. Okay, this figure, which is figure A, this is from the bracket method last time. As you can see from the graph, from the figure over here, if bracket method, you will have XL and XU. Then to find the XR, we cut into half. Okay, cut into half until you find the correct value of XR. This is bracket method. But for open method, you will be given 1 starting point. This is your XR. Okay, let's say you are given your starting point over here. You will need to calculate using the equation until you find the correct value for XR. Okay, this starting point is important because it will, later on, it will direct your calculation whether it will be diverging or converging. Diverge or converge. Diverge means what? Different direction. It will go different direction. You see here, this is your XR. But with the wrong starting point, you will get divergent trend where it will go to this side, go to the other side. It should go to this side. Whereby if you have the correct starting point, okay, you will get the conversion approaching your XR value. Okay, so it depends your starting point and it depends to your equation as well. Now in fixed iteration point, fixed point iteration, we rearrange the function of fx equals to 0 so that x is on the left hand side. Okay, last time you have, let's say, this fx equals to this. Bisection, fourth position, we use this equation. Okay, but for fixed point iteration, in order for you to find the xr, you need to rearrange the equation so that x is on the left side. Okay, rearrange. Okay, it's either rearrange or you can just plus x or divide by x until you get x on the left hand side. Okay, clear? That is the first rule for fixed point iteration. Why you need to do that? Because in fixed point iteration, you are given 1 point only. So in order to find the new point, you need that the rearranged equation to find the new x new using the x old value. Okay, this one is still iteration method. Okay, doing iteration method and check with the EA until you get the correct EA. Okay, clear? EA, as usual, this is the equation. Okay, wait, before we go to the example, I go back to this. Now, just now you need to find new in order using the G x whole, right? You are given this as your starting point. Okay, so you need to use the rearrange equation to find the second point. Let's say using the equation, you get this as your x2, for example. Okay, but it is not yet approaching the xr. Okay, so you need to do the iteration. Next point, perhaps you get over here, x3, still not closer to the xr. So proceed with more iteration until you get to your xr value. So that is why you need to rearrange the equation. The purpose is to find the new point using the old point. Okay. Now we try this example. It asks you to use simple fixed point iteration. Okay, this is the method that you need to use to locate the root. Root is xr for this function. Okay, this is the given function by using initial guess of 0.5. and iterate until EA equals to 0.1. Okay, so here this is your ES. Now what to do? First step, rearrange the equation. From fx sine power x. Now how to make x to this side? What equation that you get? X equals to sine power x. Okay. Now this is the equation that you need to use. So x here will be your x new. So the inside the right hand side will be your x old. Correct? Fx just now is 0. Remember the root is when fx equals to 0. Okay, so bring x to the right hand side or left hand side. It's up to your arrangement as long as you get the equation. Okay, this is the first step to find the equation, the rearranged equation. Okay, now do the iteration. So for the first iteration, your xi will be your starting point. This one, 0.5. Okay. Sorry. That one is not considered as iteration. Okay. Okay. Your first iteration is the one that you find using the equation over here, x new. So 0.5 over here will be the first value, iteration number 0, where the iteration haven't started yet. So the first iteration is using 0.5 to find your x new. So x1 times 0.5. What you get? Use in radian, 0.6496, correct? Okay, then proceed the same approach for the next iteration. So for second iteration here, x2, so yours will be sine square root the x1 value. So you get 0.7215. Remember, you need to calculate the EA in order to know when you should stop. For the first EA, I get 23. Okay, try to proceed. Let me know until what iteration you get your EA lesser than 0.01. consistently using 5 significant figures or 4 decimal points. Okay, until iteration 10, 0.7686, is it? Right. 7686. But I can see some of you at iteration number 10, you get 7686 or 4. So this one will give you EA around 0.003, is it? Roughly there. Okay, so again, it depends to the decimal point or significant numbers that you use. If you use consistently from the beginning 4, then you will get until 0%. Okay, so the equation here, x new, as in the slide, sometimes you will use as xi plus 1. Okay, so it depends how you label your equation. So here it can also be labeled as this. I here is the iteration number. Okay, any question? Rabia, can? Now I give you one more example. Okay, this slide it shows whether the equation and the starting point is converging or diverging. Okay, you see here for the A and C. A and C. This one is converging or diverging for A. Approaching to the XR value, right, for the A. Okay, so this trend is correct, converging. Whereby for the C, it is diverging. So the trend is wrong. Your starting point might be wrong or the equation might be wrong. Okay. Now for B and D, this one is called as oscillating patterns or spiral pattern. This is also showing either divergent or convergence. Okay, so this is diverging. Okay. Now, one more example. This one is to explain to you another step in the fixed point iteration. Sorry. Okay, this example, it gives you the fx. Okay, this is the equation, fx. Starting point. It asks you to find the xr. Now, first step, you should rearrange the equation. Okay, sorry, to add the question here, find the root using fixed point iteration. Because if it doesn't mention what method you need to use, you can use any method in your answer. Okay, rearrange the equation. Now, you have over here this equation. Rearrange so that x on the left-hand side. You will have a few options. Now, let me know what are the equations that you get. X equal x2 minus 1. Another options. Again. Root of x plus 1. Okay. Another options. One more option. Huh? Using quadratic formula. How? Is it like this? Okay, this is another option. Okay, so x equals to 1 over x minus 1. This is another option, right? So now you have 3 equations. Which one to be used? We need to check which one of the equation is correct to proceed with the iteration. Now let's try for equation number 1. You try to do the iteration. Iteration 0 start with the starting point, which is 2. Okay, for the first iteration, what you get? Iteration number 1. What you get? Huh? 1, 3. Okay, this part is important for the EA. Now calculate the EA. Huh? 33.3. Okay, next. 8. Right, what is the EA? 62. Iteration 3. You get 63, right? How is the EA? 87 point something, right? Okay, 0.3. Okay, now from here, we can see it is diverging because the EA is increasing. Okay, over here, EA is increasing. So this equation is diverging. Now this equation cannot be used. Okay, so this one cannot be used. Now, try about the second equation. Try to do the iteration, find the x new or xi plus 1, then the EA. How is the trend? Iteration 1, what you get for the second equation? 1.73. Okay, check for the EA and try to see whether it is increasing or decreasing. Wait, I need to take the phone. Decreasing. Yeah, try to do it and find the root until 6 iteration. What do you get? Second equation, you can see the EA is decreasing. So meaning that this equation is correct. EA, final EA, 0%. Or you get approaching 0. But you can see the trend is decreasing. Okay, so this equation is the correct equation. Just try for the third equation, whether this equation can be used or not. Is it diverging or converging? Okay, for the third equation here, first one you get 1. Looks like converging, but then For second iteration, you will get error. So this equation cannot be used. Okay, those equations that are not feasible to be used, we call it as a bug. Okay, so because you can see it's either diverging or error, math error. Okay, so that's why in fixed point iteration, first point you need to rearrange the equation. Okay, second step is to check for the correct equation. Meaning that validate the equation lah. Validate the equation, whether it is converging to the root XR. Okay. How to know the root is correct? You try to put back into the main equation. If it is approaching 0, then your root over here is correct. Okay. Any question? Anyone need me to repeat? Yeah, for the fixed point iteration, there are 2 steps. Rearrange and check for the correct equation. Now, actually, I have one question. This one midterm, last May. This one we continue in next class, tomorrow class. Okay, so that's all for today. I have taken the attendance. Okay, that's all. Thank you.